cool integral. And it's cool because it requires U substitution, integration by parts, and trig substitution in order. Yeah? Cool. All right. So to start, let's make the substitution that z, not u, but z be equal to root x. As you'll see, no pun intended, we'll need to reserve the letter u for later when we're doing integration by parts. But yeah, so this is our start. And from here, we can write the dz is equal to 1 divided by and it's going to be 2, that 2 is ugly, sorry, 2 root x, much better, dx. As you'll see, we need to replace dx right there, so we need to solve for dx using this equation we just wrote. Doing that, we can write the dx is equal to 2 root x dz. But wait, we'd said that root x is z, so we can write the dx as just 2z dz. Yeah? Cool. Alright, so now let's come back and rewrite our integral as follows, which is that it is the integral of arcsine. By the way, arcsine is sine inverse, right? Arcsine z times dx is 2z dz. So let's make a little bit of space. Arcsine z, let's move it a little, and then I could write that way. I could write the dz here, and I could write the 2z right here. Yeah? Cool. And now looking at this, it's abundantly clear that we have to use integration by parts. And recall that integration by parts required that we look at our integral and view it through the lens of u dv, wherein the answer will be uv minus the integral of v du. Yeah? Cool. So we need a pick of u and a dv. I think it's fairly straightforward to recognize that u has to be arcsine z, and then dv has to be 2z dz. From this, v will have to equal z squared, and du will have to equal 1 divided by root 1 minus z squared dz. Yeah? Cool. Alright, so I think we've got everything we need to rewrite this integral in the form of the right hand side, because we're saying this is in that form. Yeah? Cool. So then using the right hand side, we could write the right hand side here, that is, we can write our integral is the following: uv, which is z squared arcsine z, and then minus the integral of v du, so z squared, and I actually need to make space, so v, which is z squared, and then du is all that junk we just wrote here, so divided by root 1 minus z squared dz. Cool. So now all we have left to do is, figure out what this integral is. And I'm going to do that in black over here. Now it's clear, looking at this, that we have to do trig substitution. If it's not clear, then you should practice some trig sub. But yeah, it's trig sub, and additionally, the substitution we need to make is z equal sine theta. Doing that, we can write this here, right, in black over here, as integral of z squared, if z is sine theta, is going to be sine squared theta. Ugh, that's so ugly, sorry guys. Sine squared theta, and then divided by and it's going to be root 1 minus sine squared theta. But wait, from trigonometry we know that 1 minus sine squared theta is cosine theta. So it's silly to write this. I should just write cosine squared theta. But then it's even more silly to write the square root of cosine squared theta. We could just write cosine theta. So let's do that. And since we also need a replacement for dz, using our z, let's see that dz will have to be cosine theta d theta. How nice. Cosine theta d theta in place of dz. And it's nice because boom, boom. So our integral now turns into, or at least this part, turns into just simply the integral of sine squared theta d theta. Now, in my advanced calculus 1 videos, I do a bunch of integrals that I say are important integrals to know, and one of them is sine squared. So because of that, I'm not going to spend the time to do it here, but I'll give you the hint. To figure out what this integral will have to be, look to the cosine double angle formula, specifically that cosine 2 theta equals 3 different things, but the one that's useful here is this one, 1 minus 2 sine squared theta. Yeah, so if you solve for sine squared theta here and replace what you have there, then you could figure out that the answer to this part should be the following, which is negative a quarter sine 2 theta plus 1/2 theta plus c. Now, on this part, I'm going to use another trig identity, this time the sine double angle formula, and sine only has one version, and it's this, 2 sine theta cosine theta. That's sine 2 theta. So I can replace that there with that, and also keep in mind that this 2 and that negative a quarter are going to turn into negative a half, so negative a half sine theta cosine theta is what we'll have on this part. And then of course we have plus 1/2, and then theta of sine theta is equal to z. Theta will have to be sine inverse of z. In other words, arcsine of z. So instead of theta, I'm going to write arcsine z. And then we have plus c. And remember, all of this is simply a replacement for that there. Okay, but we need to get back completely to z, because I still have theta here and theta here, specifically sine theta and cosine theta. Sine theta is an easy fix. It's just z. So we have negative 1/2 times z. And cosine theta is also not bad, because we worked out earlier here that cosine theta is equal to root 1 minus sine squared theta. But since sine theta is z, we're saying root 1 minus z squared. So you can write that in place of cosine theta there. So root one minus z squared. Yeah? Cool. And then plus 1/2 arcsine z plus c. Yeah? Cool. Now, this right here is a replacement for over here, right? And let me actually get rid of this fella right here and write in blue what we just figured out, which is in place of it we could write and we have, I'm gonna lead, well, we have this minus sign here, and that minus sign is gonna apply to all of this, right? The plus c we can just keep as a plus c, but everything else, this is going to become positive, right? Because of that minus sign, and this is going to become negative. So I'm gonna lead with this guy since it's gonna become negative. So I could just write negative 1/2 arcsine z, and then this, as I said, is gonna become plus, right? And so plus 1/2, and then it's z times root, that's square root. Sorry guys, I'm botching up the end. I was doing so well with my handwriting, that is. I'm not making mathematical mistakes, but still. 1 minus z squared, and then plus c. The plus c I can write at the very end. Had enough room, I don't need to crowd it. So plus c there. Yeah? Cool. Alright. So the only thing left to do is to go back from z to x, because that's how we started our integral, right? But wait, that's fairly easy. We know that z is equal to root x, so this is going to become x. This is going to become root x, and then root x, and then x. If you do all that, here's the answer you should get. Yeah? Cool. I hope you enjoyed this. Take care.